Hey guys, how's it going? Welcome back. Well, we're going to show you a little bit about remote control repair. The reason for this is if you have a helicopter, even if you just bought it new, and let's just say it goes forward and not reverse, or forward and reverse works but left and right, there's issues. Instead of looking at the helicopter first, I'd look at the remote. Okay, so the first thing you want to do is unscrew your antenna. Flip it over, take your battery cover out of the way. I'll do my best to keep this stuff in the picture. Some remotes have screws inside, some don't, but pull your batteries anyhow, you're going to need to. Now the particular remote that I got here is for the Skyline U6 helicopter, which should be the same for the Red 5 and a few others that are basically the exact same helicopter. But the same repair would go for pretty well any of them. Now, we've got this opened up. Now your left side here, this is your throttle. Okay, so we're not having throttle issues, don't worry about it. Your left and right, forward and backwards. Now what you want to look for here is broken contacts, contacts that might be shorting, that sort of thing. Okay, and you got black to black, red to red. Okay, so one black wire is obviously going to control the left side, one's going to control the right. And then one red wire controls forward, one will control your reverse. So you want to really take a good look in there. Now the one thing I'm seeing here is I've got a solder joint here that's just missing one in here. So what we're going to do is we're going to take our knife here and we're just going to wiggle between there and break that little tit off. This way we know nothing's going to short out there and we'll be all good. So if you do have a broken wire, the placement is pretty simple. Okay, you can't really mess this up. What you don't want to do is slop solder on an opposing contact that's not part of that same circuit. So you'll want to get a good visual, so get some good light in there. Magnifying glass even helps. And just check and see and make sure nothing's crossed over. Wherever there's copper plating, where it's one piece, then you're okay. You know, but if it's got a separation, don't connect this wire to this tab here or this wire to this tab if they're not part of the same circuit. Okay, but you should be fine just going back on to where it came from. So, and soldering process is pretty simple and easy. The other thing you want to look at too is all your solder joints down on this board as well. Make sure that there's nothing that looks like there's little hairline fractures or cracks on the solder joints. If you have what looks like a cold solder joint, which is an extremely dull, sometimes granularly looking or sandy looking type of joint, you might want to clean that up and resolder it, and this eliminates problems. Okay. So over here on our throttle, we're only using one side of the potentiometer on here, so we're not using this contact over here. Now see if I can zoom this in better so that you can see. Okay, so this is our left and right and our forward and reverse here. Now, these two wires, these red wires, they control your forward and backward movement. These are the ones you got to check. So if you've got reverse but you've got no forward, okay, one of these is obviously not operating, and it could very well be in here as well, not just in here. So if you've eliminated the fact that these solder joints all look good and there's nothing that's shorting or looks like it's shorted, nothing broken, then you want to check your solder joints in the board here. And this board you can pull right out pretty easy. It's only a couple of screws and it'll pop out. So let's take this one out for you, just so you get an eye on where things actually sit. Now this particular remote actually has no problems with it, so, but I wanted to use this one for the video, so okay, so we know our wires. Let's zoom out on this a bit. So once you flip it over, alright, we know that our two red wires for forward and reverse go up and under here. So we trace that to the back. And that's likely going to be, looks like this one here and this one here are two red wires. So let me zoom in on that for you. Okay, so once again, this connector here and the one beside it, these are going to be your two red wires, which are controlling your forward and reverse on this remote. And then your throttle is these two black ones here. And the other two black ones, they go, oh sorry, these are your two black ones here, my mistake. So the upper row here are your two black ones, and you've got one red one over here, and our other red one right beside it, so it's down over here. So these are your contacts in this area of the board to worry about. Make sure they're soldered properly. It's a little difficult to see the precise placement because there's glue in the way here and stuff, but you get the idea of where things go. So if all this stuff checks out in here, nothing's shorting here, you've got no problems here, there's still a possibility it could be your remote. Okay, you could have a problem with your chip. This is your main controller chip here. Okay, you may have a problem in here somewhere that's causing the problem. So it could be any of these resistors or diodes or capacitors. It could be any of those things, which is why I suggest to check out all your solder joints and make sure they're good and eliminate all that possibility. And if all that checks out, this checks out, do a continuity test from this wire to this wire to this wire, and so on. Make sure all your wires are good and there's no inner broken wire. If you do find an inner broken wire, at least now you know what the problem is and you can fix that. If all your remote completely checks out perfectly fine and there's nothing else, then I would probably look into the helicopter at that point. In a case of a helicopter going reverse and not forward, it seems kind of odd that it would spin one direction and not the other. But hey, stuff can happen. But you've only got the two wires going to the motor, and they're both power wires. So the polarity is reversed actually at the PCB board on the helicopter for your forward and reverse. So check your PCB board next on your helicopter and see if everything's okay there and all your connections are good, that sort of thing. And if all that checks out, then I would suggest replacing the motor at that point in the back, and that should just fix your problem right up. Now, before replacing your motor, one thing you can do is disconnect the wires for the motor, and then grab yourself a like even an AA battery should do the trick, because you don't want to run too much voltage to that back motor. But what you do is you would put the wires on the battery for forward mode, you know, and it doesn't matter which one's which, just make sure you remember where they came from on the PCB board, or you're going to reverse things. So what I like to do is clip them and just leave a little bit so I know which wire was which, so there's a little bit of casing left. Anyhow, check for, you know, polarity, and if it does run forward and it does run reverse, then you've got a problem somewhere on the PCB board of the helicopter at that point. So, but if you don't get reverse by flipping the polarity on the battery direct to the motor only, then you definitely do have a motor issue at that point. But I would start with the remote control first, because remote controls are common. I mean, yeah, these things are made in China and the standards aren't 100%, but you know, hey, you do what you can, right? And I've actually more often have repaired remotes than I've had to worry about PCB boards on the helicopters or the motors. And I've also replaced motors too, because I've burnt them out or I've busted them because of a crash. So I would check over the remote first. That's the first place I go to, is the remote. Then I go and check the engine itself, check the polarities, make sure that when you flip the polarities with the battery that it runs forward and runs reverse, and if it does, and all this checks out perfectly fine, then I would definitely go into the PCB board next and have the PCB board replaced, because that's more likely what your problem is going to be. So especially if everything checks out in here. And you can do a continuity test on your forward and your reverse too, on your potentiometers, and that's real simple. It's usually a two-person job, because you got one person to flip forward and reverse. Well, you hold a probe on either end and listen for it to beep, and if it beeps in both directions, at least you know your potentiometer is good. So if it's good and everything else, like I said, checks out, the likelihood it's the remote is pretty slim. It's, you know, so, because I've never seen a remote yet where the PCB board inside the remote had a problem itself, other than a couple of solder joints, but you know, fix them up and boom, and we're back in business. I have seen it where there's broken wire in here. I've never seen a broken inner casing wire yet. You know, so, and I've seen shorts happen where they got sloppy when it was put together, and you know, I've seen that sort of thing happen. So these are things to eliminate and rule out first. So anyway, hope that helps you out, and thanks for watching the video. And if you got any questions or comments, feel free to leave them, and I'll do the best I can to answer them.